Hello, Year 8 scientists. I've decided to do a little video to try and help get you through your investigation. So I have here a desk protecting mat and a piece of grid paper that has numbers on it so that I can measure the diffusion of food colouring that's added to water. So I'm going to just put a plastic sheet over that so that I don't drip water on my little grid. Something that looks a bit like a Petri dish that you were using, and a measured amount of water at a certain temperature. So I've measured the temperature of this water over here, and it is 24 degrees. So I can measure a certain amount of that water. Now, I didn't come home with any measuring cylinders, but I do have a way of making sure that I use the same amount of water each time. It's important to control all of the things that can affect the outcome of the experiment. So I've drawn a little texture line on this jar so that I know I'm getting the same amount of water every time I'm going to pour it in here. That water is at 24 degrees. I'm going to wait for it to be nice and still. It's actually swirling at the moment, so I'm going to give it a minute or two to be nice and still. I might give it a quick temperature check just to make sure. This one's really hard to read. Yes, it is sitting at exactly 24 degrees. This is an old-fashioned mercury thermometer. I don't know if you can see it, but instead of having alcohol like your ones at school, you see the silver in there. It's got mercury, and it does exactly the same job. It expands. This is an old human body temperature thermometer, I think was my grandma's. All right, I'm ready. I'm going to put the blue in the water and start a timer. Should have had that ready to go. Stopwatch, that's better. All right. And I'm going to see how long it takes to get to about the third level on the grid. So 3 centimeters. I'm going to drop it right in the middle. One drop, 1 centimeter. Of course, I started my timer on time. 1 centimeter, hits it. 2 centimeters. And it's just reached 3 centimeters in one direction about now. So it's taken 34 seconds to get that 3 centimeters. But because I'm a scientist, I'm going to repeat the experiment a couple of times and take an average. I can't pause it like that. How do I pause this thing? I've measured out the same amount of water again out of the same jug, so it's the same temperature. While the water's just deciding to slow down, I'll give it a quick temperature check and make sure it's still 24 degrees. And yes, it is. So that's almost still. I'm going to reset my timer. I'm going to put my 1 drop in, start the timer. Well, this one's moving a bit faster. Maybe I didn't let it sit still long enough. That's taken 7 seconds. So I feel like I've got a really big gap between those 2 different times. So I'm hoping this third one is going to confirm for me whether I did something wrong, and I may have to repeat it a 4th time. So here we go again. The 24 degree water, same amount each time. I'm going to give it a little bit longer, make sure that it's very still. It's really hard to know when it stopped moving, but no, it's pretty boring to watch. Okay, are we ready? Reset the timer. It looks still to me. Now put the drop in right into the middle. So 2 centimeters. I'm looking at the stuff on the bottom that's creeping along the bottom. I know that the top kind of swirls out straight away, but I'm looking at the big blob that sits at the bottom. It's up to 2.5. Nearly there. $40 seconds. That seems more like the first one. So I'm going to do it one more time. The one way to know that the water's stopped swirling is there's a little tiny piece of dust floating around on top. And when that slows down, when that looks still, that's when I'll know it's time to put the food colouring in on right in the middle of the grid. There it is. There's 1 centimetre. Two centimetres. Three centimetres. And that's taken 39 seconds. So I've just done it 4 times. I've had some that were between 30 and 40, and I've had one that was 7 seconds. So what am I going to do with that one that's really different to the others? I'm going to let you decide how to deal with that, but that's 24 degrees. I've read out the numbers. I'm going to do the same thing now with this icy cold water I've got over here. And this is going to be at about 4 degrees. I know that because it's got ice floating in it. I'll just check the temperature. Dropping, dropping, dropping. Oh, thermometer says it's 5 degrees. All right. Yeah, no, I think it's reached 4 degrees. All right, it's 4 degrees. So here we go, doing the same thing again. 4 degrees. Going to put some in the glass jar. It's got a nice look. Right there on the green line. Pour the water in. Give it a minute to slow down. I might pause the video. This is not going to be fun to watch. Well, this is fun. It's nearly up to 3 centimetres. We're at 55, 56. Stop there at 58. So about 58 seconds in the 4 degree water. All right, I'm not sure where we were up to, but I didn't want to bore you watching me continue to put food colouring in water. At 4 degrees, we got 58 seconds, 63 seconds, 55 seconds, and 57 seconds. And then I used the kettle to get water to about 71 degrees. Let me just double check on my thermometer what that number was. Yeah, 71. And I got 8 seconds, 14, 11, and 16. So that went much faster. So those results are some that you can use to write your experiment up. I've only used 3 different temperatures, and that's enough. So you can put that into a table. You can work out your variables. What are the things that we changed? What's the independent variable that we changed on purpose? Did we use a different type of food colouring or a different amount of food colouring? Did we use different temperature water? Did we measure with a different piece of paper or with a different container? Did I use different amounts of water? There's only one thing that you're trying to change, and everything else you need to try and keep the same. What was the thing that we measured? And don't just write time, because it was the time that it took to do something. For this, it was to go to the number 3 mark on my sheet, which is 3 centimetres. So you need to be clear about what it is you're saying that you measured. One-word answers are not enough. You need to talk about all the things that could go wrong with the experiment. That's later on when you do your evaluation. So you put those into a table. You would graph them with your independent variable on the x-axis and your dependent variable on the y-axis. Give it a proper label, draw a proper graph. Then you can talk about the trends that you see in the data. What happened when you purposely changed the temperature of the water? What did you observe? Use specific examples from your data to back up what you're saying, and also explain why it happened. That's in your discussion. And in your evaluation, you want to talk about all the ways that this experiment can be inaccurate. So you've used, now for this, I don't know exactly how many mils that is. It doesn't matter because I used the same amount each time. But when I'm trying to pour up to that line, there is always going to be a tiny margin of error there. A drop is not really a very accurate measurement, but I used 1 drop each time. So there's a little bit of error in there. There's all sorts of ways that error can creep in. When the water's quite warm, it's cooling down as I experiment. So by the time I do the 3rd pour, I'm using water that's not at exactly the same temperature. So there's a lot of things that can interfere with the accuracy of the experiment. And you want to talk in your evaluation, you want to talk about how you can improve it and make it as accurate as possible. And that is, if you had all the right gear and all the time in the world and as many times as you had to do as many trials, you know, the ideal situation, how you could improve on that experiment. So I hope that's enough to help you get started to write up your experiment. And that way we won't need to be doing any more collecting of data and measuring water temperatures. It's much easier when you've got everything laid out. I decided to use a jug because I found that it was easier than me trying to adjust the temperature of the water every time. I decided to use a container full of ice water so I know it's going to be at exactly the same temperature each time. When I measured the 3rd one, I had to use a different thermometer because my little mercury thermometer only goes to 45 degrees and I needed to get it a bit hotter. Anyway, go with that, see what you can come up with. Make sure in your introduction you talk about diffusion and the things that might affect diffusion, and then what we chose to test in this experiment. See you later.